So what we understand in our discussion is, as lithium has unfilled states here, it is acting as a conducting material. So one may think that any material which has the half-filled shells in itself may act as the conducting material. But answer is contradictory, because if I take the example of the second material, that is silicon. As we all know, silicon is a semiconductor. It is neither a conductor nor a insulator. It can act as the both. At lower temperature, it acts as the insulators. If the temperature is high, it behaves as the conductor. The silicon material is a crystalline material. It is a crystal material. The atomic number or the electrons available in the silicon are 14. If I look to the electronic configuration of the silicon material, it leads to 1s2, 2s2, 2p6, 3s2 and 3p2. So if I start looking it from the outer orbit, the capacity of p shell is 6, but only it is filled with 2 electrons. It is half filled. One may think by this it may be a conducting material, but as we know, it is a semiconducting material, which can be easily explained on the basis of energy band theory. So as we know, if I bring two atoms of silicon close to each other, what is going to happen? The energy bands will be formed. So what I take in this case is, I'll not take all this. Let's go to this, the 3p state. If I take two atoms of silicon, and this is a silicon atom, this is the silicon atom. This has in 3p as 2 electrons, and this also has 3p has 2 electrons. Okay, now this 3p level has a capacity of 6 electrons, or it is 6n states is its capacity, but only filled electrons are here 2 and here also 2. So only the 2n states are filled in this. 4n states are empty in this. So if I draw the energy level diagram in case of silicon as we did in case of lithium, let's take along the x-axis the interatomic distance, and along the y-axis the energy. I'll take these two here. So let's take 3s here. This is the 3s state, which has the capacity of 2 electrons, or it has the capacity of 2n states. It also has the 2n electrons. Now let us take 3p state somewhere here. So this is 3p. 3p can accommodate 6 electrons, so it has 6n states with it, and but only the field are 2, so it has the 2n electrons. Now what happens when the atoms are brought closer? If I take the case of n number of atoms of silicon crystal, as the crystal formation of the silicon takes place, n number of atoms are going to interact. When the n number of atoms interact, in 3p level only 2n electrons will be filled, and 3s level 2n electrons will be filled. Now these 2n electrons, when the atoms start interacting, some of the atoms will reduce their energy, some of the electrons will reduce their energy, and some of the electrons will increase their energy. Similarly, as you go on reducing the interatomic distance, the electrons in 3s level also goes on reducing their energy, and these also goes on increasing their energy. So this is the upper band or upper part of 3s level. It goes on extending here, and the lower band of 3s, it goes on extending here. So if I draw the energy states here, this is the energy states formed in case of 3s level, which is completely filled, and 3p level, it is partly filled. It is going to be here. So this act as valence band, and this act as conduction band. The gap between the lower band of 3p level and the upper band of 3s level is of order of 1 to maximum of 3 electron volt. So this may be somewhere near to 1.02 or something. So this is nearly equal to 1 electron volt in case of silicon. So what we find here is the gap between the conduction band and the valence band come into the picture, and this band gap or the forbidden gap is very small of order of 1 electron volt, which makes our material to be a semiconducting one. Hence our discussion as to understand the silicon as a semiconductor can be easily explained on this energy level diagram. Okay, so what we understand now, lithium is a good conductor of electricity by this energy level diagram. Silicon is a semiconducting material by this energy level diagram. Let us take one more material, that is diamond, which is acting as a insulating material. So let's take diamond. Diamond is nothing but a form of a carbon. So we know that carbon valency carbon electron number of electrons available is 6, atomic number is 6. I can write the electronic configuration as 1s2, 2s2, 2p2. Okay, when you look to this again, 2p capacity is 6, but it is filled with only 2 electrons. 4 electrons are deficient here. So one must say that diamond should act as a conducting material. Again, our band theory of solids come into the picture and tell us that the gap between the 2s and 3p level is large, of the order of more than 3 electron volts, and it is going to lead to the insulating material. So I'm going to draw the energy level diagram for this. So this is the energy and this is the interatomic distance. This is E on y-axis. This is interatomic distance on the x-axis. Let's take these two, as these are the outermost one. Let me take 2p here. So this is the 2p. 2p has the capacity of 6n states, because 6 electrons can be formed there, but it is filled with only 2 electrons, so it is 2n electrons. It's having only 2 electrons. Come to the next one. This is 2s here. 2s has the capacity of 2, so its state will be only 2n states, and it has 2 electrons already filled, and it is 2n electrons. So what we understood in the previous discussion about the silicon and lithium, as the interatomic distance of diamond material, which is having the n number of atoms. If it has n number of atoms, all the atoms start interacting with each other. As you go on decreasing the distance between the atoms, or you go on reducing the interatomic distance, first 2p is going to split, such that some of the electrons out of these 2n will start reducing their energy, and the levels will start shifting downwards, and some of the electrons will start increasing their energy, and the energy levels will start moving to the upward direction. Similarly, if you further decrease the distance to s level, some of the electrons will reduce their energy, some of the electrons will increase their energy, such that the upper level of this 2n state is going to increase and the lower level of the 3s level is going to decrease. Further, if you decrease the interatomic distance, the energy is going to increase because of the nuclear repulsion in the material. Okay, we are interested in this part, as this distance, this is again the energy band formation. The band of the energies is being formed here due to the 2s level, which is completely filled, and the band formation takes place in the 3p level, which is half filled. So this acts as the valence band and this acts as the conduction band. The distance or the separation between the conduction band and the valence band is somewhere near to 5.04 electron volts in case of solid, which is more than 3 electron volt. It's very difficult to shift the electrons from 2s level to 2p level to make them to the conduction electrons. Hence, what we understand is, by this discussion, diamond is a insulating material. So in the band theory of solids, we have seen how the energy bands are being formed and how the materials are classified into conductors, insulators and the semiconductors on the basis of band theory. We took 3 examples here. One is the example of lithium, which acts as the conducting material. Another one is the example of silicon, which acts as a semiconducting material. And one more is the material, that is diamond, which is acting as the insulating material. Thank you.